Help me out, Ben.
It's time for Maths with
Bon Jovi.
Bon Jovi? I wish. Anyway, here we go with chapter 4, lesson number 2, multipliers. This is the second lesson on multipliers and it's looking at a repeated increase or decrease. So if you remember from the first lesson, we saw that we can use multipliers to work out a future value or a future amount after a percentage increase or decrease. But really we just had, for example, a car went down in value by 9%. What's it worth now? Or a house goes up by 3%. What's it worth now? However, in real life, often items increase by the same percentage for various periods of time. For example, you might have a house increasing by the 3% in the first year, and then again in 3% the year after that, and then 3% the year after that. Or the car, it might go down by 9% in the first year, and then 9% again, 9% again, 9% again. And what will it be after 4 years? And if we do have something like that, we can still use multipliers. An example, a house value is expected to increase by 5% per year for 3 years. If we wanted to work out the value then, well again we can use multipliers. We start at 100, we add the percentage, we divide by 100. What lots of people do though is they use that multiplier and then they just multiply it by 3. Or they take the 5%, they work out 5% of the value and they times that by 3. However, at the end of the first year, the house is going to have a different value. So you need to work out the percentage of that new value. And again, after the second year, again, it's 5% of that new value. So the percentage remains the same, but the amount, the 5% of that total, changes. If you want to work out the value after year 1, what you would do, well, using multipliers, you know you're going to have your multiplier, 100 add on the 5 would be 105, divide that by 100 and you get 1.05. And then you would multiply that by the original value of the house, whatever that may be. However, after year 2, well, it's going to be 1.05 multiplied by this previous amount. So if I just leave just now the previous amount as that, 1.05 times the original value, whatever that works out to be, well, if I want to work out 5% of that and add it on, well, again, I would do 100, add 5, divide by 100. So I do 1.05 multiplied by this. Remember, this was the previous amount, and I'm multiplying that by 1.05. If you do that though, there's a quicker way of writing that. Because you've got 1.05 times by 1.05, what's a quicker way of saying that, Ben? Brilliant, you could square it, so it's 1.05 squared. And that is then multiplied by the original value. So to work out the value after 2 years, you take your multiplier and you can square it, and then times the original. If you want the value after 3 years, well again, you're adding on 5%, but it's 5% of this previous amount. So that previous amount was the 1.05 squared, or 1.05 times 1.05 times the original value. But if you then want to work out 5% of that and add it on, well again, the multiplier, 100 add 5, divide by 100, would be 1.05 times by all of that. But again, there's a quicker way of saying that. If you look here, you've got 1.05 times 1.05 times 1.05. Bethany, what's that then? Brilliant, that is 1.05 cubed. Brilliant. And that will then be multiplied by the original value. So you can see that if you want the value after 3 years, you do 1.05 to the power of 3. It's the multiplier to the power of 3. There is a pattern. If you wanted to work out the value after 4 years, what would you do with the multiplier? To the power of 4. Brilliant. If you wanted to work out the value after 5 years, you would do the multiplier to the power of 5. Excellent. So we can change our formula ever so slightly. Remember, the multiplier remains the exact same. It's always starting at 100, add or take away your percentage, and then divide by 100. But what we can do is to work out the new value after a repeated period of time, well, we can do the multiplier to the power of that length of time, and then multiply it by the original value. Example 4. Examples 1 to 3 were in the previous lesson on multipliers. So this is the fourth example using multipliers. The value of a £130,000 house is expected to increase by 5% per year. How much will it be worth in 3 years' time? So again, we're wanting to work out a value in the future, so we can use multipliers for that. So to use the multipliers, we start at 100, we add or take away the percentage, add. Why do we add? Because it's increase. Brilliant. So we do 100 add 5. and then we divide that by 100. 100 add 5 is 105. Divide that by 100 and you get, brilliant, 1.05. To work out the new value then, we have our multiplier, the 1.05, and because it is asking for the value in 3 years' time, we do the multiplier to the power of 3. Then you multiply that by the original values. So you've got the 1.05 to the power of 3 multiplied by the £130,000. If you work that out, key it into the calculator, you get £150,491 and 25 pence. Yeah. Let's try another one. Example 5. Douglas bought a car for £27,000. Its value then dropped by 14% each year for the following 5 years. Dun dun dun! How much is it worth now? Once again, we cannot just work out 14% of the £27,000 and then times that by 5 because the 14% changes each year. For the first year, it's 14% of the 27,000. But then after that first year, it's 14% of whatever that value is. And then the following year, it's 14% of whatever that value is. So we could always do that the long way by working out 14%, taking it away, 14%, taking it away, 14%, taking it away. You get the idea. Or we can use multipliers. To use our multiplier, we always start at 100, add or take away a percentage, and then divide by 100. For this one here, Tony, what would you do? Brilliant, you do 100, take away the 14 because it tells you the value of this vroom, vroom car is dropping by the 14% each year. So 100, take away the 14 and then divide by 100. If you work that out, you get 86 divided by 100, which gives you 0.86. Good. Well done. Thank you, Cameron. For the new value then, well, we've got our multiplier, that is the 0.86, but because it is going down by 14% each year for 5 years, well, the multiplier goes to the power of 5. After that, we multiply by the original value of the car, and the car was bought for that 27,000. So it's the 0.86 to the power of 5 multiplied by 27,000. Key that into the calculator, and you get £12,701 and 53 pence to 2 decimal places. And remember, money always has 2 decimal places. So that is your answer. Example 6, Nikki's annual salary is £42,000. Her boss has promised her an increase of 1.7% per year over the next 6 years. So what can she expect her salary to be in 6 years' time? And this time, give your final answer to 3 significant figures. Once again, you see that it's a percentage increase. It's going up by the 1.7%, but that is per year and is over 6 years. So let's use multipliers. Start at 100, add or take away a percentage, and then divide by 100. Because it's going up by 1.7%, we can do 100 add on 1.7, and then divide by 100. 100 and 1.7 is 101.7. Divide that by 100 and you get, good, 1.017. That is what our multiplier is. We then want to do that to the power of 6 because it's the 1.7% per year. And it's asking us what's it going to be in 6 years' time. So that will be to the power of 6. After that, what do we multiply by? Nikki. Good, we multiplied by the 42,000. Good. And then, if you work that out, you end up getting £46,470 and 25 pence to 2 decimal places. Again, money's got 2 decimal places. However, this question is here saying give your answer to 3 significant figures. So, to give our answer to 3 significant figures, find the 3rd significant figure. So the first number that we come to that's not a 0 is the first significant figure. Beside that is the second, and beside that is the third. So this here is the 3rd significant figure. It is this 4. Think back to primary school when you dealt with units, tens, hundreds, thousands, and so on. This 4 here, the 3rd significant figure, is in the hundreds column. So what the question's really saying is round this number to the nearest 100. Because we've got 470, we know that's closer to 500, so we would have £46,500 to 3 significant figures. Yay! Ooh, that's a lot of money. It is, Nikki. Example 7. Walker's Crisps, or Lay's Chips, aim to decrease their fat content in their crisps by 7.5% each year. If the current fat content is 9.9 grams, what is their target amount for 4 years' time? Give your answer to 2 significant figures. So we can see that they're wanting to decrease the fat content by 7.5% each year. And it's asking us what will that be in 4 years' time. So once again, we can use multipliers. Dun, 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 dun. We start at 100. We add or take away the percentage. What do we do here, Sophie? Good, we do 100 take away the 7.5 because they're wanting to decrease their fat content. They're not wanting to increase it. No, that'd be bad. So 100 take away the 7.5 would give you 92.5. We divide that by 100 and you get 0.925. The fat content then, after 4 years, you would take your multiplier, 0.925, and what would you do then? Do that to the power of 4! Good, you would do that to the power of 4 because it's saying it's 7.5% each year, and what's it going to be in 4 years' time? So it's to the power of 4. And then you multiply that by the original value of 9.9. If you work that out, you end up getting 7.2477 and so on. But the question here is saying to give your answer to 2 significant figures. And if you work it out to 2 significant figures, once again, the first number that comes to that's not a 0 is the first significant figure. Beside it is the second significant figure. This here is what we want to round to. And this number is in the tenths, or it's in the first decimal place. Think about it whichever way you like. So the question is really saying, what is this number to 1 decimal place? And to 1 decimal place, it will be 7.2 grams of fat. Yummy. Try some of these questions in the Likey Nat 5 book. It is page 330, exercise 31B, or any alternative textbook you like. Try some of them, see how you get on. Just remember your formula. Have fun. Bye. Ben, let's go and listen to
Bon Jovi.